Just to gauge the room, about how many people are familiar with the term object-oriented programming? Great. How many people have done object-oriented programming? Awesome. Great. That's much better than I thought it'd be, to tell the truth. Okay, so today I'm talking about using object-oriented programming, surprise, surprise, and SAS to do things that you cannot do alone with either of them. So we're going to take the awesome power that SAS has of data manipulation and the awesome power that object-oriented has, particularly Microsoft's VB .NET. So today I built two different applications for you, so I have two different presentations. One is mainly just a proof of concept, and that one's called black box analytics, of taking a complicated analytical task and doing it in a few clicks. The second task, as my friend Charles pointed out, some things have not been automated by Miner and Guide, particularly ProcMI, multiple imputation. So I built an application that automates that for you. So first we're going to go ahead and look at black box analytics. Okay. This is the program I built, Black Box Analytics. And what we're doing with this program is we're building the best regression model that we can. So we have two different, we start off with two different sets, a training and a validation set. And what we're going to do with that is use the built-in feature proc-reg selection adjusted R squared. And what that'll do is it'll build multiple models out of all our variables, all possible sets, and rank them by highest R squared. Then after that, we're going to validate them using root mean squared error. So when we start the program, we're presented with this. This is our first screen. So like I said, we select our test set and our validation set. For this program, they both have to be CSVs. They both have to have one Y column. That's going to be your predictor variable. And the rest of the columns is going to be X1, 2, 3, 4, 5, 6, 7, and so on. And those are what we're going to use as our items. Okay, next is our options tab. So as you see here, we can have transformations. And what that does is for each box you select, it'll transform all your X variables, not your Y, all your X variables in that way and throw them into that adjusted R squared formula. Next is max test. We'll really go into that later, but just to let you know now, what that will do is pull the X amount of tests you want and validate those. So if you wanted a quick test, you could do about 50. If you wanted all the sets that SAS will put out, you can just put 99999, and it'll pull all of them. The speed difference isn't really that much, but it's just a feature that I added. Safe SAS output, that doesn't affect your formula at all. What that is it will create a HTML file of everything that SAS does, and it'll save that where you pulled your validation set from. So let's go into the program. This might get a little complicated if you weren't one of those people that raised your hand. So this is the inside of the program. It uses 4 different objects. And if you're familiar with Microsoft's programming, you've probably seen this before. And what this is, we have a form home object, one form object where we start everything. Class SAS talker, that's the heart of the program right there. That is the only object that actually communicates with SAS. We have class SAS model, which inherits from class SAS talker, and that's going to be our model builder. Class SAS test item inherits, it calls class SAS talker, it doesn't inherit. And that's going to run all your validations. I'll go into that some more. So this is our class SAS talker. It's run by SAS's IOM, so their object model, if you're familiar with that, and SAS Workspace Manager. What that does is it allows us to build a virtual SAS workspace. And then using the IOM language, we can communicate with that workspace. It's pretty cool. But so since we're starting with a CSV, we're going to run a proc import first, and that's going to pull that data set into a workspace. We're going to count the X variables, so making sure you have some in there, because obviously you can't run aggressive on the X's, right? And we want to test for one Y, because it's a simple linear regression. We need a Y variable. Then we're going to perform those transformations if we ask them. So are we going to square all our X's, cube them, whatever we want to do. Once we have that, like I said, we're going to run that proc reg with selection adjusted R squared, and that's in our class SAS model object. And like I said, it also inherits from class SAS talker. So if you've seen this before, what this is it builds a model for each. It builds a model for each possible combination of your X variables for every single one. Oh, and to explain this, squared 2 means x2 squared. So you have x1, x2, cubed is the cubed of x2. And then you have an R squared here. And the higher the R squared, the higher it is on the list. And it just rates them all the way down. So as you can see, the list could get pretty darn long. That's why we have that max test option. So if we say max test 50, it'll pull the top 50 and validate those. We say 9999, all of them. All right, now we get to validate. So we validate by root mean squared error. And that's for each, and it creates a class test item for each validation. It's called from class SAS model using class SAS talker, like I said. And what we're going to do is we're going to find the lowest root mean square error for formula. And these are our final results. So our best subset, that's our intercept, and that's our x1 beta, x2 beta, x3 beta, and squared x2 beta. And we also see our root mean squared error here. And then if we did ask to have our HTML output, it would look like that. And we've all seen that before. Now at this point, you might be asking yourself, well, why did you do this? Why did you do that? I'd have done some different formula. Well, the awesome thing about this, I mean, it's proof of concept, for one. You wouldn't necessarily really use this in practice. The point is that with this model, you can go on to build anything you want for a company. You can make any task easy with just a few clicks. So let me give you an example of the other application I bought that's really, it's ready to go. I've actually used it before a couple times in my work outside of this for class. And this program is called Auto Imputer. Sorry, let's get the whole picture. So anybody here familiar with multiple imputation? All right, it's a good number. So multiple imputation, what that does is it takes a data set with missing variables and it fills those in for you. Now, you might say, oh, okay, well, I do that with mean substitution, right? That's what we've done in basic statistics. Well, mean substitution, I'll tell you today, is a horrible idea. Absolutely terrible. Who's done ANOVA? Yeah, good. If you do mean substitution, you run ANOVA, you're working backwards. The point of ANOVA is to find difference. You're pushing everything to the center. Why would you do that? It just doesn't make sense. And there's also listwise. It's like, well, I'll just throw out all the variables that are, I'll throw out all the observations that have missing data, which a lot of statistical analytics procedures will do that anyway. So even if you're not throwing them out yourself, they're getting thrown out. Well, that works, right? So, no, that does not work. Say we do a survey. Say we do the religion and suicide survey. If you're only looking at those people who completely filled out that survey. So that means that's a small subgroup of that population. That's a certain type of person who'd sit there and fill the whole thing out. Not the college students ready to go. You just fill out a couple things, maybe he misses one. That means all those people you're not looking at. That is an extremely biased data set. Not to mention, it's taking out a large chunk of your data. Because how often do we have complete data sets? It's pretty rare. Okay, so a little bit of background. Rubin and Schaefer, these are the guys who innovated multiple imputation. There's a lot of advanced math behind it, more than my level. But just to do a little bit of explanation, we really won't go into it. It uses expectation likelihood as to set your initial formula. So what that does is it looks at all possible ranges of missing observations. So x1 could be there, x2 could be missing, x3 could be there. It could range any way. And then it uses the values in that observation to predict an expected likelihood. Then we use multiple imputations of that to find what it could be. And then you can do multiple things with that. You could create multiple imputations and then do a proc-reg, proc-mi-analyze, but that's different. All we're doing today is we're going to fill in those spots. And I say all we're doing, but it's pretty cool. So this is the data set we're used to looking at. All these little dots here. That means we have no data for them. So we need to fill those in. First screen we're presented with is we just select that data set that's missing data. Next, we set a library. Back to this. This could actually be a CSV file or a SAS file. So you have your choice there. And you don't have to tell it what it is. It'll know. It's a smart little guy. So we set our library. That's where all of our work's going to be saved. Our new data set and any of the output if we select it. And then we just have an out file name. This doesn't actually change really anything in there. All this is for admin use. So if you want it to be, hey, this is my new file with proc imputation, it'll save it as new file with proc imputation. We hit the next button. We have our user options. So there are a lot, so stay with me. First thing it does, I need to update this, and you'll probably see why. First thing is it reads in all your variables. So these are all your variable names. And you can ignore variables. So we probably, I've read some papers, some people don't want to impute y's. Some people don't want to impute your predicted variable. You don't want to use print, you usually want to leave that missing. That's debated. So you can select it or not. Also, some things you just don't want to impute. Maybe you do want to mean impute something, or maybe you want to know that it's missing for some reason. So you can go ahead and select it here. Now, you say, wait, there's a country there. You can't mean impute. You can't impute country. You can't. This is the old one. The updated version will only put numerical values in there. Multi-mutation went out to categorical variables. I'm sorry. Just won't do it. Non-metric, not category, excuse me. So here are our multiple imputation options. We have a seed. If you're familiar with pseudo-random procedures, that's it. Use the Monte Carlo change, all that good stuff. So if you don't set the seed, it will randomly select a seed for you, and your output will be different every single time. If you wanted to repeat the procedure multiple times and get the same output every time, you could set a seed, 42 or whatever, and every time you run it, you'll get the same output. Alpha is default 0.05. That's where we get into that math that is above my head and probably most of the people in this room. I mean, it's not a math convention, it's SAS convention. Round is pretty cool. So we have, let's say we have year, CO2, electric, and you could round all these variables to, let's say you put 1. They'll all be rounded to 1. You put 0.01, they'll all be rounded to the 0.01 place. But you say, hey, year, I don't want 0.01, but CO2 needs to be 0.01. So what you would do is you'd put a dot, because you don't want any rounding, space, 0.01, and then electric needs to be 0.1, space, 0.1. You could do that. And it'll actually do that for all of them. You just have to pick the order. Or you could just leave it blank and it won't round anything. Imputations, default's 1. If you leave it as 1, it'll look exactly like your old data set, but with that data magically filled in. If you do multiple imputations, about 3 to 10 is what you would do for multiple imputation procedure. If you're going to use proc reg, proc mi analyze, you could put that number there. Okay, user options. These won't affect your formula. Won't affect proc mi. These are just, like I said, user options. So open folder locations, you can probably guess what that does. That's going to open the location of your new file. Show SAS code, we've seen that before with the HTML file. I'm sorry, show SAS, that's save output, excuse me. Show SAS code, what that's going to do is that's actually going to print out the SAS code that this program used. So if it won't do it for a new data set, so the whole numerical thing here, it's not going to rerun that. But it will allow you to recreate exactly what you did in this program by just copy and pasting this in the base SAS. All right, so let's go into it. Not so scary now. So like I said, the main purpose of this program is to automate. So it doesn't do one of these tasks that require all these options. So as you can see, we only have one class, and it's class SAS talker. It looks familiar, right? That is the exact same object I used in the other program. That means once you go through the hard labor of creating this guy here, it is so easy to create whatever kind of user interface you want. Just all you have to do is recreate. The rest are just simple forms. That's it. So, SAS IOM, SAS Workspace Manager. We've seen that before. So the first thing we're going to do is create that SAS data set and import it as a CSV. We're going to get the variable names, check if they're metric, put them in that list, and ask if you want to ignore them. Then we're going to run our proc mi with all your options. Pretty simple, right? All right, results. Look at that, magic. All those dots turn to numbers. It's pretty great, right? There's our SAS code. Like I said, if you wanted to repeat this procedure without rerunning the program, copy to clipboard, paste it in the base SAS. Day's done. And this is what your HTML file will look like if you decide to save it. Thank you very much. Do you have any questions?